What would happen if a force equal to thousands of nuclear bombs erupted from underneath the United States? According to geologists, it's not a matter of if, it's a matter of when. This is Yellowstone National Park. Each year, more than 3 million people see its blue hot springs, dense pine forests, and erupting geysers. It is America's first national park, a protected ecosystem that functions much as it did for millennia. Visitors walk on boardwalks just feet from pools hot enough to dissolve a human body. They stand on ground that trembles with more than 2,000 earthquakes a year. They are, in the words of one geologist, standing on the chest of a sleeping giant. The geysers and hot springs are merely the giant's steady breath, signs of the immense heat engine working miles below. This is not just a park. It is the largest active volcano on the planet, and it is overdue for an eruption. The geologic record shows that the Yellowstone volcano has produced continent-altering explosions in a repeating cycle. The last one was 640,000 years ago. The interval between the previous eruptions was 660,000 years. We are now living in the window of the next cataclysm. For the first time, based on the forensic evidence left by past explosions, we can piece together a detailed picture of what the next super-eruption will look like. This is a simulation of the first hours of that disaster, and the years of darkness that will follow. But to understand that future, you must first ask a question. If this is the largest active volcano on the planet, where is the mountain? The answer is tied to a force that comes from deep within the Earth. It is called a hotspot, a stationary plume of molten rock rising from the planet's mantle. For 17 million years, this hotspot has remained in one place, but the ground above it has not. The North American plate, the continent itself, has been slowly sliding southwest over this plume at about the same rate your fingernails grow. Imagine passing your hand slowly over a candle flame. In that way, the hotspot has burned a trail of destruction across the American West. As the continent drifts, the plume periodically melts a tremendous magma chamber in the crust just a few miles below the surface. This creates a chain of volcanic fields. The Hawaiian Islands were formed by a similar process, but the geology there is different. The Earth's crust under the ocean is made of basalt. When basaltic magma erupts, it is fluid and flows like hot mud. You can watch it advance and walk away. The continental crust is mostly rhyolite. Rhyolitic magma is thick with silica and traps huge amounts of gas. This viscous magma plugs the volcano's plumbing like cooling tar. Pressure builds to extreme levels. When it finally lets go, the dissolved gases flash into steam with explosive force, expanding to hundreds of times their original volume. Rhyolitic volcanoes do not ooze. They detonate. For 17 million years, the Yellowstone hotspot has been detonating. It has produced at least 142 caldera-forming eruptions, a trail of geologic scars stretching from Nevada across the Snake River Plain of Idaho to its current location in northwestern Wyoming. The Snake River Plain, today a flat, fertile volcanic landscape, is the healed-over track of the hotspot's previous devastation. People of the distant future may grow potatoes in Yellowstone. But for now, a vast reservoir of magma 3 to 8 miles below the surface continues to power the park's hydrothermal wonders. The hotspot has produced 3 super-eruptions in the Yellowstone region. The first, 2.1 million years ago, was one of the largest volcanic events ever known on Earth. It ejected 600 cubic miles of magma, a volume 2,500 times greater than the 1980 eruption of Mount St. Helens. The explosion was so powerful that it obliterated 30 miles of a mountain range that once stood here. The ground collapsed into the emptied magma chamber, creating a crater, or caldera, nearly 60 miles long. A second, smaller supereruption occurred 1.3 million years ago. Then, 640,000 years ago, the volcano exploded again, spewing 240 cubic miles of lava and ash. This eruption created the Yellowstone caldera we see today, a depression 50 miles long and 30 miles wide that occupies the very center of the national park. For 70,000 years, the volcano has been quiet. But it is not extinct. It is a living, breathing system. The ground in the center of the park is constantly rising and falling as magma and superheated water shift miles below. Between 1923 and 1984, the caldera floor bulged upward by more than a yard. Since 2004, parts of it have risen another 7 inches. The area has the greatest concentration of geysers in the world, all powered by a reservoir of magma that scientists believe could be 10 times greater than what has been expelled in the past. The system is primed. Another catastrophic explosion is, according to the United States Geological Survey, almost inevitable. The only question is when. The prelude to the next great blast will begin slowly over months or years. The first sign is an increase in seismic activity. The thousands of small tremors that normally rattle the park each year give way to intense earthquake swarms, hundreds per day. The ground begins to shudder violently. Faults rupture the surface. The land itself begins to heave. The caldera floor swells upward at an accelerated rate, inches per year becoming inches per month. The ground stretches and cracks. Fissures spread across the surface, some miles long. From these fissures, red-hot lava begins to ooze, setting forests ablaze. This is the first stage, but it is merely a warm-up for the main event. As lava escapes to the surface, the pressure inside the vast magma chamber begins to drop. This is the tipping point. The release of pressure allows the dissolved gases within the viscous magma to boil out of solution violently. The process propagates exponentially. As more gas escapes, the pressure drops further, causing even more gas to escape. The chamber doesn't fizz. It doesn't roar. It detonates with the speed and power of a nuclear explosion. The eruption begins as a machine gun burst of blasts from vents around the edge of the swelling caldera. In terms of energy, each blast is the equivalent of a nuclear bomb. The magma chamber empties with the force of hundreds of thousands of times the explosion that leveled Hiroshima. The continuous explosions obliterate the landscape. 30 miles of mountains are blown into the upper atmosphere. 600 cubic miles of magma, a block of rock more massive than Mount Everest, is ejected from the earth. Water vapor released from the magma billows into the sky, generating colossal thunderstorms within the plume of smoke and ash. Glowing ash shoots upward and blasts outward. The first wave is a pyroclastic surge, a cloud of hot gases and vaporized rock. But what follows is even deadlier. How fast and how hot is this flow? It moves at hundreds of miles per hour and exceeds 1,000 degrees Fahrenheit. The hot flows uproot and incinerate whole forests, killing everything in their path. They radiate outward from the vents, funneling through the valleys of the Madison, Gallatin, and Yellowstone rivers to the north and the Snake River to the south. The cascades of glowing ash travel as far as 80 miles before settling, welding together to form a solid sheet of rock hundreds of feet thick. For miles in every direction, not a living thing remains. There is only a lunar landscape of hot rock, mud, and ash. For hours or days, the explosions continue. Eventually, the vast magma chamber beneath Yellowstone has emptied enough that its roof can no longer support its own weight. The ground, everything that hasn't already been vaporized, fractures along the edges of the chamber. An area 50 miles across collapses. The surface drops like a piston for hundreds of yards into the vacated chamber below. Even the 10,000-foot Mount Washburn, an ancient extinct volcano on the caldera rim, is sheared in half. Its southern portion plunges into the fiery earth. This collapsing mass acts like a plunger, expelling even more magma, which explodes from the fractures at the edges of the new caldera. The surrounding land, already covered by ash, cascades in avalanches into the immense fiery pit. Yellowstone National Park is gone. In its place is a scene from the apocalypse. The immediate destruction is only the beginning. Dark clouds of ash and volcanic glass, blown into the stratosphere, begin to drift east on the prevailing winds. The coarsest particles fall first. The area that was once the park is buried 20 feet deep. Within days, a snow-like ash fall blankets the western United States, from the Pacific coast to the Mississippi River. For those living within 100 miles of the eruption, there is no escape. The pyroclastic flows incinerate everything. The towns of West Yellowstone, Gardner, and Cook City are gone in an instant. Cities like Cody, Wyoming, and Bozeman, Montana, are in serious trouble. Beyond the zone of total destruction, the primary threat is the ash. It is not like the soft ash from a wood fire. It is composed of fine, abrasive particles of rock and volcanic glass. Within hours, a foot of it falls on Denver and Salt Lake City. It paralyzes everything. Radio and phone communications go dark as electrically charged ash disrupts radio waves. Power generators shut down. The ash soaks up rain, becoming heavy and causing roofs to collapse. Transportation stops. Roads are buried. Wet ash makes surfaces dangerously slick. Airborne ash reduces visibility to zero. The fine particles clog air filters and abrade metal parts, destroying internal combustion engines. Airplanes, trucks, and cars are useless. For days or weeks, the western United States is cut off. But how can we know what this blanket of ash would do to the continent? The answer lies not in a computer simulation, but in a prehistoric crime scene. 12 million years ago, an eruption of the Yellowstone hotspot blanketed the Great Plains in a thick layer of ash. In 1971, paleontologist Mike Voorhees discovered the result, a fossil bed containing the perfectly preserved skeletons of hundreds of animals, rhinos, camels, horses, all gathered around an ancient waterhole. They were not killed by the initial blast. They died slowly, over days and weeks. As the animals grazed, they inhaled the fine, abrasive ash particles. The jagged shards of volcanic glass settled deep in their lungs, causing massive internal bleeding and respiratory failure. They developed a condition called hypertrophic pulmonary osteodystrophy, a painful affliction where new bone grows on the skeleton in response to suffocation. The animals, sick and feverish, were driven to the waterhole for relief, where they died together. The smaller animals, with smaller lungs and higher breathing rates, died first. The largest rhinos were the last to fall. A modern eruption would repeat this scene across the West. Domestic livestock and wildlife would be doomed. Herds would be wiped out by starvation, fluorosis from poisoned grass, and respiratory failure. The human toll from the ash would be catastrophic. Those with respiratory illnesses would be the first to suffer. The fine particles, too small to be filtered by a cloth mask, would lodge deep in the lungs of anyone who breathed the outside air, leading to widespread sickness and death. The disaster would quickly escalate from a regional to a national crisis. The Great Plains, the breadbasket of the world, would be buried under inches of ash. Where the ash is more than 6 inches deep, crops and pasture grasses die. Harvests fail. Fields will lie fallow for years, reclaimable only at enormous expense. Major rivers like the Mississippi become choked with sediment, as much as 800 times their normal load. The channels fill with ash, causing massive floods. Barge traffic, the primary transport for the nation's grain, halts. Power plants that rely on river water for cooling shut down. Water treatment facilities are overwhelmed. A global famine becomes a certainty. The United States, the world's largest food exporter, sees its agricultural heartland destroyed. Nations that depend on that food face mass starvation. The worldwide death toll could reach 1 billion people. As the ash gradually settles, a more insidious threat remains. The eruption injects millions of tons of sulfur dioxide high into the stratosphere. There, it combines with water vapor to form a fine aerosol of sulfuric acid. This haze encircles the globe within weeks. It does not block all sunlight, but it reflects enough to cause a dramatic drop in global temperatures. History provides a small-scale example. In 1815, the volcano Tambora erupted in Indonesia. It was the largest eruption in recorded history, yet it was a fraction of the size of a Yellowstone super-eruption. The following year, 1816, became known as the year without a summer. Frost occurred in New England every month of the year. It even snowed in June. Wheat, corn, and hay crops failed across Europe and North America. The failed harvests followed the ruin of the Napoleonic Wars and led to urban famine, food riots, and widespread theft. In an overcast and dreary Switzerland, a group of friends confined indoors by the incessant rain, including Lord Byron and Mary Shelley, held a contest to write ghost stories. Shelley's contribution became the novel Frankenstein. A Yellowstone eruption would trigger a volcanic winter lasting not 1 year, but a decade or more. Average global temperatures would drop by several degrees, enough to devastate agriculture worldwide. The combined effects of the ashfall and the volcanic winter would threaten the fabric of civilization. The historical record is filled with smaller eruptions that offer a grim preview of a super-eruption's power. In 1883, the explosion of Krakatau in Indonesia, a magnitude 6 event, generated tsunamis over 100 feet high that destroyed 165 coastal towns and killed more than 36,000 people. The sound of the final blast was heard nearly 3,000 miles away. In 1902, on the Caribbean island of Martinique, the eruption of Mount Pelée unleashed a pyroclastic flow that swept into the city of Saint Pierre. It destroyed the city in minutes, killing 29,000 inhabitants. There were only 2 known survivors. The disaster was compounded by the island's governor, who had downplayed the danger to prevent citizens from evacuating before a pivotal election. In 1985, Colombia's Nevado del Ruiz volcano erupted. The blast itself was small, but it melted the mountain's glaciers, triggering enormous mud flows called lahars. These lahars raced down river valleys at 40 miles per hour, burying the town of Armero and killing 23,000 people, 3/4 of its population. The town had been built on the debris fan of previous eruptions, and a hazard map drawn just a month earlier showed it was directly in the danger zone. Each of these disasters, caused by volcanoes 1,000 times less powerful than Yellowstone, demonstrates the catastrophic potential. A Yellowstone event would combine all these lethal mechanisms, pyroclastic flows, lahars, and global climate change on a continental scale. Scientists who monitor the volcano agree that an eruption is not imminent. The ground is rising and the earth is shaking, but these are the normal vital signs of this restless system. The Yellowstone Volcano Observatory uses a network of seismometers, GPS stations, and gas sensors to watch for any change that might signal a move toward eruption. The goal is to provide a warning. Humanity has never witnessed a super-eruption. We have never seen the specific warning signs that precede one. We do not know if the final prelude will last for decades, years, or mere months. Geologists may not recognize the difference between the signals for a smaller eruption and the start of a cataclysm. An evacuation of the western United States would be an undertaking of unprecedented scale, an impossible task without certainty. Certainty is a luxury geology does not afford. We can only watch the sleeping giant, listen to its breathing, and know that one day it will awaken. The geysers and hot springs of Yellowstone are not just wonders of nature. They are reminders. They remind us that the ground beneath our feet is not static, that the forces that shape our planet operate on a scale we can barely comprehend, and that our existence on this world continues by geologic consent, subject to change without notice.